MATLAB has built-in functions for generating two-dimensional plots. Such plots include bar charts, XY, and polar plots. The tables below give you the functions used in two-dimensional plots. Linear plots. The plot command generates a linear XY plot, and there are three variations of this command. In this command, the vector x is plotted, and in this command, a linear XY plot is graphed. And finally, in this command, multiple linear XY lines are graphed on the same plot. Now consider this example. In this example, the response of an RC circuit is to be plotted. First, we need to define the x-axis, and in this case we will use the vector t for time, which will have an initial value of 0, final value of 4, incremental value of 0.5. Next, the function y is defined, which is a decaying exponential of amplitude 6. The plot command is then used to sketch the linear XY plot. A suitable title is then added to the plot, and the axes are appropriately labeled. Text can be inserted within the body of the plot, and finally grid can also be added to the plot. Next, we'll run the program on MATLAB and observe the plot. As you can see, figure 1 shows you the plot or the response of an RC circuit, which is a linear plot. The axes are appropriately labeled, and also there's a text embedded in the plot, decaying exponential. We can increase the resolution of the plot by changing the incremental value of the vector t. As you can see now, the linear plot has more resolution. We could also change the line style of the plot. Here we have dashed plot. We could also change the color of the line. In this case we have red. We could also combine the attributes red and dashed plot, as you can see here. For more details on how to use the plot command, you could always refer to the help within the command window, as you can see here. Multiple plots. The subplot command allows the graph window to be split into 2, 3, or 4 subdivisions. The arguments I and j specify that the graph window is to be split into an ij grid of smaller windows, while the k argument specifies the kth window for the current plot. Now consider this example. First, we define our x-axis through the vector x. Then we define our two functions y and z. Y is a square of x, z is cube of x. In this example, the graph window is split into 2 subdivisions. These commands plot the square of x, while these commands plot the cube of x. Now we execute the example on MATLAB and we obtain this figure. As you can see, the graph window has been split into 2 quadrants. The square of x is at the top and the cube of x is at the bottom. Logarithmic plots. Logarithmic and semi-logarithmic plots can be generated using these commands. Log command will generate a plot with both the x and the y axes logarithmic. Simulog x command will have the x-axis logarithmic and the y-axis linear, and Simulog y command will have the y-axis logarithmic and x-axis linear. Now let's consider this problem. In this problem, we want to sketch the frequency response of a capacitively coupled amplifier. In this case, we want to plot the gain against frequency, and we want the x-axis or the frequency to be logarithmic and the y-axis or the gain to be linear. This table here shows you the data for the frequency and for the gain. Now consider the MATLAB script which gives you a baud plot for the capacitively coupled amplifier. Vectors f and g define the x and the y axes respectively. Simulog x command will now plot gain against frequency, and in this case the frequency axis will be logarithmic and the gain axis will be linear. Appropriate title and labels are then added to the plot. Executing the script on MATLAB gives us this plot. As you can see from this plot, the x-axis is logarithmic and the y-axis is linear.